Our last speaker in this series is Dr. Chris Pyke from the U.S. Green Building Council.
All right, so it is a complete privilege to talk with you today, and I am going to cop to a couple of things right off that this is an unenviable position. You guys had a great lunch. You're in comfy chairs. You just heard something interesting, and now I'm supposed to keep you awake until coffee. So that's not going to be easy, but I'm going to try. Okay, so actually, here's the carrot I have for you, which may or may not be worth it. No modeling. For the next 20 minutes, I will not, no modeling. I will actually inflict upon you data. And I think actually in the spirit of the dinner time conversation Dr. Spector told us last night, we're going to get a little empirical. And let me start with this, which is, this is a concept that a few of you heard me say this yesterday, is that what I believe we do at the U.S. Green Building Council, which is by the way, not an agency of the U.S. government, it is a nonprofit 501c3 membership organization, 18,000 member companies and 78 chapters and a whole bunch of other people working together to move this. So the idea is that out there in the universe, there is a prevalence of practice across multiple performance dimensions. So what is this? This is a histogram or a density plot that represents the prevalence of practice. So how many actors, how many buildings, how many projects are performing where across a spectrum. And our goal is to induce, to cause, to do interventions that create a permanent and self-sustaining shift in the prevalence of practice across the dimensions of what we understand as green. And so unlike, I think the point was made earlier, that agnostic as to what is good, better, and best, we're not. We actually have an opinion, and our opinion is that we want things to go in a certain direction with respect to energy efficiency, renewable energy, materials, waste, human experience, and so forth. And so we're going to chase that curve through the next 20 minutes and see if we can go from a conceptual curve that is the basis for what our movement has done over the last 2 decades to a data-driven version of that curve that we can seek to understand and track over time. So I'm going to start by placing you, though, for those folks who aren't familiar with green building as it is right now, I want to talk about the incredibly unstable moment that we find ourselves in. We are at an inflection point, basically a movement that is unstable. We are ending what I would call the era of firsts. For the last decade, we have had an awful lot of fun in green building. We have got to do the first LEED certified building in this case, first LEED certified laboratory in the West Coast, first platinum building. We had the first green building in Harvard, the first green building in Peoria, the first one in Tampa, the first animal husbandry facility, the first wastewater treatment facility. We don't get to do that again. And actually, what we are entering into, we have combined those firsts into a pattern of unique green buildings that have become regional patterns, have combined to be national patterns, and ultimately spread into 110 countries around the world in collaboration with many different countries who are advancing green building. So we have created through an era of firsts where basically many different projects were first of a kind. Many different projects were kind of a unique, this is our first time through this process, and we could all feel good about that. And at the end of it, one of the things USGBC is known for is we hand out a plaque and we say, this is your gold, silver, or platinum plaque. That's great. Okay, I'm not going to talk a whole much about that because that era, not the era of handing out plaques, but the era of it being exciting that it was the first time. Just to kind of reflect on how I think about that, if I told you one man survives cancer, we have a special publication for that. We call it like the National Enquirer. If we cure cancer in a population, that is worthy of our attention as scientists and scholars, and we put that in a journal like The Lancet or something, right? So these are a bunch of, maybe in a certain way, not to demean them, but this is one man being cured of cancer. What we're interested in is this. We're interested, as we saw earlier today, in altering the prevalence of practice in the design, operation, construction of the built environment at this scale. All these lights represent built environments, from doghouses to skyscrapers that we are trying to alter, and we are trying to shift that distribution, not just around energy efficiency, but across all the dimensions, all the green dimensions that these urban areas are impinged. And so let me talk about how I think we're doing that. But I also want to start by giving you a sense of where I think we are now. So I was trying to convey what I thought about the nature of data flowing from the built environment today. And this is about as close as I could come. So we have an asset that typically costs millions, hundreds of millions, sometimes billions of dollars. Typically, the only the only data stream we have off that is a wire that goes to an entity that sells us electricity, right? And I think back, well, what does an analogous communication system look like? Well, the telegraph. But then actually, the telegraph isn't actually dumb enough. It actually is instantaneous communication, and it's bidirectional. So our current information about buildings is actually worse than we were in 1944. So the question is, we are rapidly, with the assistance of many people in this room, moving toward this kind of reality, where the entire nature of our understanding of these built environments is, should be, and will continue to be instrumented, data-driven, and empirical in nature. And the nature of that flow of information, there's a couple things I would point out that make this more than just a movie graphic, are that the information density about the building is complemented by information density about the people in the building. The people are the sensors. You know, when we raised our hands and said how much we liked this space or didn't like this space or whatever, when we really get down to it, your experience of that is the only legitimate sensor of that. I don't care about ASHRAE 55 or ASHRAE 62 or the other things. Your experience is the only legitimate barometer. Our collective experience is it. So we are trying to collect multiple channels of information. What are we doing? What is a green building? What are the flows of, what are the green dimensions of performance that we are trying to collect, trying to foster? We are interested in the efficient use of energy. We are interested in the source of that energy, be it renewable or something else. We're interested in the flows of water, waste, the indoor environment, the acoustics, the thermal, the ventilation rates. We're interested in your experience in here. And actually, I would partition our interest in your experience from many others. As we get into this, you'll find that, at least from my personal perspective, our goal in the green building community is to not just provide you with a satisfactory experience, but our goal is to understand what it means for you to have an exemplary experience, an exceptional experience in this space. I'm interested not just in your experience in this space, I'm interested in how you got here, your level of physical activity, the public health concerns, and I'm also interested in the financial dimensions and biodiversity and many others. Okay, that's a lot to be interested in. But that's why green building is a really big tent. It is more than any one of those things. And when we say green buildings, that's what it is to me. This density of information is where we're going. The challenge, as many people have said, is what do we do with it? How do we turn that? It's one thing to collect the information, but I'm not agnostic as to the state of that information. I am directional. I want this information to move in a certain direction. So this is where, in my mind, one of the things we have at our disposal are rating systems. Because everyone thinks I'm going to talk about rating systems, I'll talk just a little bit about rating systems. What rating systems do is they provide a lens to interpret some of that data. So a rating system is something that USGBC and others around the world create. And what we do is we plop a value judgment on top of a piece of data. And so the simplest case would be basically what we're trying to do is to say that observation is good, that one's better, and that one is best. And we're going to, through a collaborative consensus-based process and all that, define that good, better, best spectrum. And we are going to create competitive advantage and reward for those folks who are best over those who are good, and in far excess of those who are none of the above, right? And so a simple example of what I mean is we can take a data stream. So the US EPA creates a benchmarking tool called Energy Star Portfolio Manager. For any given building in the commercial building in the US, like an office building, we can score it between 0 and 100. Many of you guess old hat. The question, so that's great. We have a line of data. We took the utilities, we benchmarked them against the building stock in the US, and we get a number between 0 and 100. A rating system's job is to basically sit on top of that data stream and say, if you're 69, yeah, that's all right. If you're 86, that's an average for a green existing building in the US. That's good. And if you're 100, that's best. So that's the simplest case of dozens and dozens of those kinds of interpretations that we make. But that said, the result of certification is we are pushing beyond the notion, and that actually really what I want to focus my remarks on is we are ending that era where the result of certification is a glass plaque on a building. that act of certification is the beginning of a data stream that we will use in all sorts of different ways. And keeping in mind why one of the fundamental reasons that we do this is that we have a vast market failure in the building industry that relates to the absence of information. We don't have information on the comparative energy performance of different buildings. I can't tell you how much water that building uses or how much people love it or whether it provides great acoustics. I can't know that. And so what I'm trying to do is create the kinds of labels, the kinds of disclosures that allow us to efficiently allocate resources to the better performing assets. And I'm not going to just do that alone. I'm going to do that in partnership with others who have different bandwidths. But the bottom line is we are going to create our goal, our purpose is to create a great deal more transparency about multiple dimensions of building performance and to take it to scale. Not a conceptual problem, a brass tacks problem about I need to know more about that asset so I can decide how I'm going to allocate my resources. Am I going to buy space in it? Am I going to invest in it? Am I going to run away from it? What the heck am I going to do? And what I can do once I have that data pipe, every certification that we get, every building we come in contact with, we can offer them something important in return. We can offer them context. And in my simple-minded world, I'm not an engineer, and I understand the world more simplistically. I understand that there are things on the left-hand side of this graph that if I look at a distribution of performance across a density distribution of projects, I have some on the left that if I continue to create projects on the performance level over here, I will drag my average down and I will be moving in the wrong direction if my goal is to achieve higher levels of performance. If I get delivery of projects on the right, over time, I will move my average in a positive direction, and I will accomplish my goal of market transformation and moving the population in one direction. And so what I have is a universe of less successful solutions and more successful solutions. As an organization, what can I do with that information? I can create competitive advantage and differentiation for the ones on the right, and I can ignore the ones on the left. So how do I see this playing out? What I want to do is create mechanisms, interventions that reward those successful projects based on performance on multiple dimensions that you and I get to choose. We don't have to agree on the dimensions of performance. You can like energy efficiency more than I do. I can like toxic reduction more than you do. But we need that transparency so you can make that decision and I can make this decision and I can choose my project. And what I want is to move the entire mass of performance over time forward, and I want to see it with empirical data in near real time. Okay, so with that aspiration, I promised no models, and then I gave you 10 minutes of concepts. Yeah, so there's no free lunch, right? Well, maybe there is. This is the one place you can really say there's a free lunch. So I want to show you how we are actualizing those concepts through a set of tools that we call the Green Building Information Gateway. I consider it an environment where we are developing and demonstrating solutions to do what I just described to you. And you can get a sense of where we're at, and you can also envision where we're going. So this is something that we've been working on for, I don't know, about a year, and we are very committed to working on in the future going forward. So the good thing about this part of the talk is, actually, if you don't like my talking, you can pull out your iPad right now and go to gbig.org and follow along. You can actually click on any of these. These are a variety of apps and whatnot that you can try at your leisure. And I want to focus on these 4 key functionalities. First, the number one thing that we've needed to create is transparency. I need to not just walk up to a building and see an Energy Star plaque or a LEED plaque. I need to unpack that plaque and learn more about it. Okay, that's pretty easy, right? At least it seems easy. Okay, so I can take a view like this of downtown Chicago. I can take these buildings that have plaques on them. I could also show you the Energy Star ones. You can go in there, you can use your iPad like this, hit that little locator button and look at the characteristics of green buildings around you. I've started to use our own toy and I love it. Actually, I'm downtown New York and I'm like, what is this building? Okay, and so what I can do is I can pick a building like the Merchandise Mart. I can click on it. I can zoom to the street level using our friendly street view. I can see my little icon right there, and I can also see the very creepy heads on spits, which is that's actually what happens if you're a successful luminary in Chicago, if they put your head on those things. And I can then drill down to get information about those assets. So I've begun to create a framework for providing asset level transparency in real time. In other words, the story doesn't end with a plaque. The story begins with a plaque because that gets you on the map. The next thing I can do is I've now created a data anchor. So I can now attach all sorts of other people's great insights. You don't like my metrics, you don't like the things I collect, fine. What I've created is a data anchor, and this is not rocket science for all of us, but the practicality of it is a bit of rocket science. And so I can say, well, let me look something up and let me attach a walk score. So a third-party metric about the relative walkability of that site, and that's only a tease as to anybody's third-party resource. So if you're out there and you're saying, I have a better way to represent the performance dimensions of this asset, be it walkability, physical activity, financial value, I have a mechanism now through web services and other IT protocols to expose this to you. I can share this to you as a JSON object. I can consume your API and attach information to it. So that's the kind of architecture that we're doing. The next thing is that I want to be able to not just explore it, connect to it, but I want to compare it, right? Because now I'm going to start that process of creating competitive advantage for the better actors. And the example I'm going to give you today is a quick one, is based on, say, a jurisdiction. So I have 2 municipalities. I want to basically inspire or promote or show Chicago how it compares to its rivals in New York City with regard to green building activity. I could be looking at energy efficiency. I could be looking at the number of accredited professionals, the workforce that they've created. But what I can do is I can track and trend this over time. And so you can go create this comparison. And there are numbers down here. Don't worry about them. What I want to show is that there's a basis for going in and comparing place A to place Y and looking at the level of activity across multiple metrics. Ultimately, the goal is to customize this. Is it how many green building projects, how many Energy Star projects, how much revenue from green businesses do you have there? This is a platform from our world to create that comparison, to provide a dashboard. The other thing that you'll immediately appreciate is that basically Chicago and New York are just instances of groups that happen to be geographic. So if this is company 1 and this is company 2, or your portfolio, your collection, and my collection, the same function works. So the basis is the most simple thing I'm trying to do is to allow you to inspire and to compare yourself to others and see where you stand. But I'm really not satisfied by that. I want to go back to that curve. I want to find that curve and move it. And so let's spend the rest of our time talking about that. So going back to the curve conceptually for the last time, what I'm really trying to do is differentiate these 2 dimensions. The how side, which is the high performance side, where what I'm trying to do is provide you with increasing rewards for being a high performer. And so let me give you an example of one of those types of projects. So this is an example of an existing green building that was certified in Chicago. So this is the FBI building. Okay, so up to now, historically, we would have given you a plaque and said, platinum building, that's great, good on you. That's fine. But what I want to understand is I want to begin in increasing levels of detail to unpack what that means. On what dimensions did you perform, and how were you performing relative to your peers? So what I can do is, as one example of many, I can break the performance of this building down into, in this case, the 6 categories that you guys are familiar with: energy, materials, indoor, site, water, innovation, and critically, I can find those curves. I can use the data. Every day, we get about 1.5 million square feet a day, which is added up to over 1 billion square feet of real estate over the past decade. And I can use that to establish the distribution of performance. In this case, the word points essentially refers to metrics. I'm collecting 30 different channels of information on energy performance, of which I have a positive result. They did something affirmative in 25 of those channels. And so the key issue is not just where they were against my requirements, but where they were against the rest of the market. So that distribution is the distribution of achievement in energy and atmosphere for all buildings that's certified in that existing rating system. So I can say that I understand just how good that building is. It's good. I mean, pretty much 95% of the buildings that pass through our system are worse than it on that dimension. I can do that for materials. I can do that for IEQ, sustainable sites, water. And what you'll notice is that, and we'll come back to this, we can start unpacking these distributions and ask, why are those distributions where they are? What is the combination of technology, cost, behavior that are causing these distributions? And conversely, I can also turn around and talk about why. Why are some buildings not? Like, I mean, this is obviously I'm comparing green buildings to green buildings, but I'm still equally interested in why someone is doing a below average green building for some market. And let me give you an example. So here's a case where a building is doing the bare minimum for energy. They're still exceeding code, in this case by 15%, at least on a design basis, but they're lagging the rest of the market. So I look at this and, gosh, if I was the building owner or investor, I wouldn't accept that. I mean, regardless of what else you know, right? I mean, I don't even have to put units on there, right? If your design team comes in and says, this is our project, okay, I would assume that most people in this room would reject that project and say, come back, try again. But I can also look on the same project. They've actually done above average work on materials. They've done dramatically below average work on an indoor environmental quality. They're average for their site. They're way below on water efficiency. My goal with this is to provide this information early in the process, in the proposal, in the design phase, and ask folks, to confront this comparative situation, because I'm going to hold them to it later. Yeah. So let me give you an idea how we can drill deeper. So I don't have to limit myself to individual, there's lots of different performance dimensions, and that's what I find rich about this space. I can worry about energy efficiency as represented by Energy Star. I can worry about a performance dimension like a ventilation rate, or in the case of something we call a greenhouse gas index, I can take the 29 different channels of data that we collect that relate to greenhouse gas emissions, weight them by their relative contribution to greenhouse gas emissions. So I can weight density and transportation accessibility very high. I can rate energy efficiency very high. I can rate materials or water somewhere a little bit lower. I can rate them in proportion to their relative importance. And I can combine them into a synthetic index where 100 equals everything you could do weighted by its importance, and 0 represents doing nothing. And I can start to dig into these distributions in two different ways. The first thing I can do is the blue, I can look at it over time, and I can look at it by segment, and I can say, well, we didn't design a rating system to have a mean of roughly 48, which is what this distribution has. But the market is telling us, based on its voluntary uptake of these things, that that's what it's willing to provide at this time. And I can begin to unpack it. And I can also see that using the same yardstick, you don't have to worry about the idea, but the idea is we're using the same yardstick, the same set of criteria, that in the time period 2006 to 2008, versus the time period 2009 to 2011, I've seen a small positive shift in that distribution. So projects are doing more with regard to things that reduce greenhouse gas emissions in those two time periods. So I can know this, I can track this, I can slice this, I can present it back to you, and I can ask you to position your asset, your proposed asset or your real asset in this space. I can also break this down, and so I can say the two biggest components of a GHG index include the location and the design of a site. So how transportation accessible is it? And I can start finding some interesting patterns. If I look at the distribution of US projects, that's the blue, and I look at the distribution of lead projects in China, there's a few hundred of them there, and I look at that compared to the distribution of all other international projects, I can start to see systematic differences in the way that those projects are adopting GHG abating strategies writ large. So I don't think so I'm sorry, this should actually say GHG index, but the idea is the same. The idea is that this thing right here is saying U.S. projects are adopting slightly less of what's available than our counterparts in China, than our counterparts internationally writ large. There's a bunch of good reasons behind that, but the crux is we can unpack it and you can compare. So if I'm just comparing the differences in these shapes are important to providing that context that creates competitive advantage. A similar story, actually probably more germane to some folks in this room, is the adoption of energy and atmosphere activities. That's energy efficiency, commissioning, renewable energy monitoring, and so forth. And one of the things you can see is that we have a distribution that's centered on about 35%, which is actually this number of points, 5 or 6 points. And what we have is this incredibly long-tailed distribution. So we begin to we can begin to get in a position to use this information to ask what's going on in this tail, what's going on in this tail, why is this peak centered where it is? Because we didn't design it to be centered this way. This is information content on the receptivity of these groups for this, and this is something that we can track in near real time. Okay, so where I hope I've gotten you to in the remaining 50 seconds before I take your questions is the idea that we 20 years ago started a movement with the goal of taking a distribution that was actually completely devoid of data, and through a process essentially ready, fire, aim, of trying to set benchmarks and drive projects toward it. Now, 10 years after we really operationalized that system, we're at a point where we can track real distributions in real time and ask and use that as the basis for understanding the underlying mechanisms. And it's just in time, because this is the playing field that's going to play out in. So our interest is in creating the kinds of scalable information analytics that we're going to need to tackle this problem. So with that, I really welcome any questions.
Hi, this is Amit Mishra from Los Alamos here.
Oh, sorry, thanks.
So my question is, do you have any influence on the policy? Like, some of these things have to be imposed because you might come up with data, but people may not want to do it because of cost.
Yeah, so there's two answers to that. So when we look at moving a curve, we understand policy as one intervention. And particularly in the building sector, policy is, there's kind of public policy, then there's building codes and standards and so forth. And what we're trying to do is, but fundamentally, we're trying to mix those whole things together. And so when we say, do we have impact on policy, there's a couple different ways we absolutely have impact on policy. But on the other hand, the goal is to create competitive advantage for the high-performing actors in the space so that it is desirable, economically beneficial to adopt those higher performance practices. I think that it is candidly, I think it's a mistake to understand these distributions as much as we might like to understand this kind of stuff in terms of ROI. This stuff, this distribution of energy efficiency, distribution of renewables, these real projects out there in the world are partially responsive to narrowly framed kind of rational understandings of ROI, and they're actually responsive to a lot of other stuff. So the last part about regulation, there is obviously a very close coupling between codes and standards, like building codes and energy codes, and this. And our understanding is that this creates room and the literal for raising the bar with regard to standards, and we've seen that. So for instance, right now, basically the average building, this number of points corresponds to about 30% better than ASHRAE 90.1 2007, which is the kind of most widely used energy code. So what that basically said is there are thousands of projects out there who are readily capable in delivering today 30% above code. So we can take that back into the codes process and argue to raise the floor. And what are we going to do? We're going to move 30%. We're going to keep raising so that the competitive advantage is realized 30, 40, 50% over. So we're not going to be done. We're going to move together. So a lot to unpack in that, sorry.
This is RC from Eastman Chemical. You are using and rating on a dozen factors to qualify whether the building is green or not. Mm-hmm. And do you see whether those scoring on each of these factors could change over the life of the building, number one? And number two, whether the LEED certification or the net energy zero audit is this one-time analysis audit, or you go back in 5 years, 10 years and see whether you have to...
Okay, so two questions. So the dominant issue is that the idea of certification over the last decade has grown up around span of control, essentially saying we understand a building design and construction time period, and we have a set of metrics and a set of things that are under control, and then we have an operations period under which a different set of conditions are under control. And so I think it's absolutely critical to understand the goal is to connect those things together, but the goal is that they are necessarily different because the currency of design and construction, AEC construction, is different than it is for operating, and those are necessarily segmented. So to your point, yes, there are different performance metrics. Yes, there are different issues that are under control in different phases, and that's why we've had a proliferation of segmentation. So now, today, we have 14 different rating systems that deal with everything from interiors to homes to warehouse, distribution, data centers, commercial, schools, retail, neighborhoods, and so forth, and it gets to your point. The other part about the time value. So within the last year, there's 2 or 3 profound things. The entire green building movement is moving, as John told us earlier, toward a focus on performance. And where the first issue is, how does the building perform? And the next issue is, how did you perform well? So up to now, we asked kind of what were we putting in, inputs, and then hoping that it derived outputs that we liked. There's a lot of good reasons for that. But what we're doing is creating a whole new paradigm where performance drives the show. Because of that, there's also another way to answer the last part of your question. The market has basically said that certification of buildings, whether it's LEED or Energy Star, the market has valued that at about a 5-year shelf life. I certify a building today that creates marginal benefit in terms of rent, effective rent, tenancy, and so forth. And we can detect that through economic analysis. That premium basically falls away within 5 years. So whether you are following our recommendation, which is to recertify your building every 3 years, or whether you're letting the market be your guide, which says if you don't recertify in 5 years, anything you did to create advantage last time is not believed by the market, one way or the other, 3 to 5 years in, you need to be doing this. My feeling is we need to approach a state of continuous certification, a state of continuous evaluation. That to me is more like a diving board on a submarine, like green lights, ready to dive, right? Green lights, we are in a constant state of high performance. And what we're asking is, how do we work back from a technology we have today, an episodic scorecard sort of approach, to a set of automation that allows us to assess continuous performance? That's the transition.
Roman Stocker, MIT. This was extremely interesting. You emphasize a lot the gradients within a pool of buildings that already belongs to the green buildings.
Yep.
Wouldn't there be more value in trying to get more buildings into this category? And secondly, by emphasizing that buildings within this category need to be top performers, might you not be putting off those who are about to decide whether they should enter the pool of green buildings?
Right. I get this question a lot. So there's two ways to answer that. One is I would love to have more buildings enter the pool of green buildings for a bunch of reasons, because first and foremost, it is the first step in this transparency. It is the point we become aware of them. It's the point we know anything about them at all. So I want that to happen. But at the same time, you actually can do this mathematically as well, saying that we have the diversity, the heterogeneity of green building performance has increased. We created the voluntary system, it has heterogeneity. And so I do believe, have a sufficiently large cohort of green buildings that we can stimulate internal competition, and that's actually the right thing to do after doing this for 10 years. Because I'm not gonna look at you and say, I don't think a certified building is great shakes. And I don't think that the delivery of that is a minimum level. And I think it is fully within our power to create competitive dynamics within the pool of green buildings, because people like ourselves want to compete in that pool. So I want to compete to bring more entities onto the radar screen, whether that's through certification or just through advanced data channels or other types of things. But it's a both and, I think, is the answer to your question. It's a both and. I want to stimulate competition within the pool. I want to enlarge the pool.
Sam Geckler Cummins, in order to push the distribution the way you'd like to see it go, where do you see the weak link in clients or customers asking for it, or builders available to provide it?
I think it's a demand problem, largely. I think that the level of sophistication, I probably answered that too quickly, but I think my gut reaction is that many of these are demand problems. The market is capable of delivering more sophisticated, higher performance solutions, and they have not, and we have a variety of reasons that inhibit demand for those higher performance solutions. I think there are exceptions. I think what I said is true with regard to energy performance. I think it is probably much more debatable when it comes to water performance, because water performance, basically we've set standards that basically everyone is meeting. They're all like basically 70-80% of projects are meeting our highest standards with regard to water performance, and we're not really sure where to go with raising that bar. So in other words, that's not demand driven. We're not sure if the market would demand higher, but the market isn't really clear about what next to offer. Here in this space, we know that higher performance solutions for energy with regard to efficiency and renewables are available, but there's a lack of demand for them, and these cases where people are performing at this level are special in some way. So I think the answer is you can find situations on different performance variables. The last one I'll add to that is say, if we think energy is demand limited, water is some sort of limitation in supply of good idea, and occupant experience, how much do you love this space, is completely limited by the lack of data. we don't, to the point that was brought up earlier with Michelle, actually, the issue was saying, I don't have the data on enough spaces to get people to really compete on the quality of these spaces in this same way. If I did, I could open up that competition, but I can't right now. Please.
Hi, Anurag Jain with Weidlinger Associates. Question is, what's the correlation between USGBC LEED certification and green building codes such as the Cal Green?
Yep, good question. So green building codes and standards there's two answers to that. The first way, you got to first put it in context. Today, there are two universes of green buildings. This summer, we reached a parity point in USGBC where there are as many square feet of existing green buildings, i.e. existing buildings that have been recognized as green, as new construction. That's going to continue in that parity going forward. So for half of the green buildings we deal with, codes are not really relevant because they are existing buildings that are performing against operational benchmarks. For the half that are new construction, which increasingly over half of that new construction volume is overseas, it's in China, Korea, Indonesia, Brazil. It's in developing world markets where that's really relevant. So that's an interesting codes twist too. But the issue, so for that fraction that is new built, what we understand is what we're trying to create is a complementary relationship between green codes and voluntary standards. So we're trying to create a delta where the voluntary standards get the market experienced reaching up to higher levels of performance, which allow us to raise the green codes levels. So USGBC has been a very strong supporter of ASHRAE 189, of IGCC, and to a degree Cal Green. And so the goal has been to move these up in lockstep where the voluntary reach standard is tied to incentives and other things that are helping the market stretch, and the codes are bringing up the floor. We still don't know, although we know a lot about, we're doing a study right now that compares all the intricacies of codes and voluntary standards. We still don't really have, we have essentially no buildings that have been built to green codes yet. So there is a major transition step between the adoption. Right now we have green codes as hypothetical documents. The adoption of those codes and then people building to those codes is the next step. We understand what a LEED building is. We don't really understand what a green code building is yet. So that's a long conversation.
Hi, Oliver Williams at Microsoft Research. I think the last couple of questions actually spanned my question, but I'll say it anyway. The thing that sort of occurs to me is a little bit is that, obviously we saw sort of the zero net energy examples and these great examples of gold and platinum LEED places but in some sense the goal is obviously to have good energy efficiency for the whole globe taken as a unit, and that to have 0.0001% of buildings being outstanding and everything else not so great is better, that is not as good as having like 50% that were good. So obviously you want these things to sort of trickle down a little bit, and it's not entirely obvious that some of the techniques that you're rewarding by providing things like platinum status are scalable. Could every house in a large development scale to having all of the great things that you're rewarding there? And obviously, as you said, that fills into code and other things, but it's just
right. So that's a good question. I think we have to ask ourselves some profound questions about scalability. Although I will point out a couple things in the commercial space. So right now we know that green building practices are written into the specs of 70% of commercial new construction in the U.S. That's from the analysis of building specification by McGraw-Hill. And so the idea, whether green building as a kind of integrated, holistic concept like a LEED Platinum building or a BREEAM excellent building is possible. I think that they play an important role as a test bed and need to be understood as pilots and test beds and market early things that are easing market adoption. What we definitely see empirically is the uptake of those practices into down market. And so how that plays out is a critical concern. I mean, we all are asking ourselves, what we want, what you just said, we want that broad scalar adoption. We understand it as a diffusion of innovation problem, and we understand how do we create multiple interventions to bring it down market. And we can look at very specific, I think we can hang our hat on some things that are maybe sound trivial, but were actually quite effective, like the broad-based adoption of low VOC paint. It's something where the green building industry helped get people comfortable, create demand, incubate demand for low VOC paint, and now we see a substantial adoption of low VOC paint across the market. Those are not the kind of really swing from the trees examples we want, but maybe 10 years on.
Whitney Colella, Pacific Northwest National Labs. Thank you for a very interesting talk. I'm just curious how you calculate the GHG index.
Yep. I'm happy to follow up with you and give you details. The crux of it is what we do is we take a prototypical reference building, in this case a typical US office building, and we conduct a series of, use a series of models to estimate basically it's 175,000 square foot US office building with a certain specified occupancy and a certain specified use on a 1 acre parcel of land that uses irrigated water, all sorts of different things. So what we do is we specify a prototype, and we basically divide out that carbon footprint that would be associated with that reference building. So in a sense, that reference building is the target for LEED for new construction. And so that building has a proportional carbon footprint, this much from transportation, this much from the building systems, this much from solid waste, this much from the life cycle of materials. And then what we do is we basically look at the ability of individual credits, those strategies, to abate different pieces of that distribution, of that pie. And so the larger a chunk of that pie you're going after, the greater a coefficient you have in the index. So basically you have a vector with 29 coefficients. Each one is a achieved or not of a LEED credit. And so what we track is the achievement of those credits, and we translate it into a proportional value for GHG reduction. We also have a variant of this that actually works in tons, but you have to actually specify the prototype more. So again, if folks want to see, there's an online demo of that tool available, and there's a lot of documentation for the index. The thing I'll mention about the index is one of 13 indices that make up LEED 2009. So there's another 12 that are equally accessible, and there are 25 more that are in development, and we actually have working with academic colleagues to develop indices against other issues, such as we're working with the New York Department of Public Health on a active design physical activity index that works the same way. So that was a lot of information, but the idea is that indices as ways to interpret credit achievement are very important to us, and I'm happy to follow up with anybody who finds that remotely interesting, because I can get really nerdy about it.
Jamie Hestick, Arkansas. I was just, when you're doing this a lot of the big buildings, and this is kind of going back down to the house example, is in my experience, people want to be green. They really do. I mean, but they in houses really don't have any idea how. It's like it's seeming like a lot of the stuff that's been talked about throughout all the speakers is higher upfront initial costs, energy savings down the line. But I mean, is the result of this also going to result in some sort of heuristic of, okay, if I want to be green, my first best thing for spending a little bit more money up front that's on my mortgage is this, and then second is this, when you have a slide, right?
Yeah, well, I think that, exactly. I think that, okay, so homes are really important. Homes are different. So we have a whole group in San Diego who focuses exclusively on homes, and homes have a lot of different issues. But what I found motivating, I'll give you where I want to be with respect to homes, is I want this same context. I live in my home, and I look down my street, and there's a half dozen other homes that are essentially the same as my house. I have no idea which ones of those homes perform better or worse than the others. And I have no idea those homes that do perform better, how they do it. So in the same way that I want to offer this context to a commercial project, I desperately want to offer it to residential. Because what I lack is, I mean, this is, some of this is channeling O-Power or channeling other people in the field, but the idea is basically saying, what I lack as a homeowner, someone who's trying to make those decisions, is any sense of context or perspective on how green I really am, or what the highest performing people like me are doing. Those are questions that we can inform, we can unpack, and then say those high performers, what systems are they using, how are they going about doing it, blah, blah, those sort of things. So my dominant connection between this and what you're talking about is that desperate desire to give homeowners and occupants of homes context so that they can begin to put themselves in context and act on that. I think a lot of other things come from that.
We've got time for about one more question.
Sure. Oh, I'm sorry, there's two of you in a row, so whoever's first. Yeah.
Jadid Desai from University of Maryland. I had a question, actually a follow-up. Typically for a residential house, if you look at the cost of constructing a LEED certified home or green to a sufficiently large extent than what is currently probably out there for a typical home, what is the cost differential?
That is a great question. Okay, so we have a study going on in California right now. So in November, come back and I'll give you the answer. But there's actually two ways to do it. If you do a bottom-up cost estimate and you ask, basically how much does it cost to get into an Energy Star or a LEED home relative to a conventionally built, the rough order of magnitude is $1,500. Because you're really paying for envelope tightening, you're paying for a few prerequisite type activities. It's actually an incredibly low number. And so a bottom-up estimate of the sort of basal amount that it takes to get up to an Energy Star level of efficiency and those things is of that order of magnitude. So that's a pretty trivial amount of money, and that's when you really get down to it. You can obviously take that to much larger sums of money when you put on photovoltaics and you start doing mechanical ventilation and lots of other things. That number can skyrocket, right? But that basal level, the interesting thing though is, so when I made this distinction between a bottom-up cost estimate, which is just what does it cost to get there, the real interesting question right now is how the market values it. Because a lot of developers are going around and saying, I'm going to try to sell you that green home for 20% more. And so they're trying to get quite ambitious markups. And so it's going to be quite interesting to get some real market signal about what the market is really willing to absorb. We know what those numbers look like in the commercial office space because the residential space has been such a disaster. Like we launched LEED for Homes in 2007. Yeah, that was good, right? So we've been battling through a tough market. And if you want to understand what the shape of that market looks like, gets wonky, but the issue is it's a bimodal market. Basically, the home activity is dominated by multifamily affordable and relatively expensive custom builds. The market rate homes are the hardest to do because they are the most first cost sensitive and they're dominated by production builders. And so that is changing slowly, but that's the nature of the market. So we have the most information on these kind of weird ends of the market. That's more than you wanted.
All right, well, please help me thank Dr. Pyke and all of our speakers.